All Things Data podcast. In the spirit of Daniel Kahneman, Peter Diamandis, and Google Moonshots, brings together leading data scientists, technologists, business model experts, and futurists to discuss how to utilize, harness, and deploy data science and data-driven strategies to enable digital transformation. The hosts are Dr. Manjeet Rege, Associate Professor of Data Science, and Dan Yarmoluk, Director of Business Development of IoT and Data Science. The podcast is produced by the Graduate Programs of Software of the University of St. Thomas in St. Paul, Minnesota.
Hello and welcome to the All Things Data podcast. My name is Manjeet Rege from the University of St. Thomas, and this is a show where we'll talk about data science, big data, IoT, amongst other things. I am joined by my co-host, Dan Yarmoluk, and you'll hear from him soon. I would like to introduce our guest today, and that is Sean Owen, who is the director of Cloudera. Sean, it's very good to have you.
Thank you very much. I appreciate it. I hope I can add a couple ideas or insights from my experience in data science on Hadoop and at Cloudera to the discussion.
So at St. Thomas, the company Cloudera has been our academic partner in the Masters in Data Science that we offer here at the Graduate Programs in Software. And so we thought, having Sean Owen as one of our guests would be the ideal thing to do. So I thought we'll start out by having you, Sean, say a little bit about your background and the kind of things that you have done in the past, and then of course the work that you do at your current position as well.
Sure. Yeah. I think the first thing to admit about myself is that I'm really a software engineer by trade. And even though I guess my title is data scientist these days, I'm certainly coming at this from a software engineering angle. And I think that's actually been an advantage over the past 5 or 10 years. So I started work a long time ago, but I've started getting into Hadoop in about 2009 and helped develop one of probably the first machine learning library for Hadoop called Mahout. And really cut my teeth on Hadoop there. I had actually been doing MapReduce and distributed file systems at Google before that, but it was really fun to see that start to apply to machine learning. And things change over time. So I've been doing a number of things, and ended up trying to start a small company, and it came to Cloudera as part of that. And have more recently been working on Apache Spark. But the pattern there is that I am interested in the tools. I'm interested in data science at scale, and that is really what I think Cloudera can help people with, figuring out how to do all this stuff at scale using these new frameworks. It's been fascinating to watch the world of data science evolve over the past, even just the past 5 years or even a couple years, as the world of big data engineering, my world, kind of collides with the world of classic data science and R and Python. It's an exciting time for data science.
So, Sean, often we hear, from a listener's standpoint, the terms data science and big data used kind of interchangeably. What's your view on how would you differentiate what is defined to be data science as opposed to big data?
Sure, these are big terms. I think they mean different things to different people. They're sometimes overused. They're related though. So what is big data? Well, it's, I guess you could say it's a lot of data, but hey, what's a lot of data? Yesterday's big is tomorrow's small.
Right.
I tend to think of big data as a movement that started right after the dot-com bust, roughly speaking, early 2000s, when as it got, the availability of data increased dramatically with the rise of the web and then mobile. Suddenly there was a huge amount of data being generated that one could collect in this new internet linked world. And it also began to get cheaper and cheaper to store data, not just because hardware prices and drives got bigger and hardware prices dropped, but because we started to get open source software that helped us do that, like Hadoop, for example.
Right.
So big data was really a name for this phenomenon. So suddenly we went from a data scarce world where it was expensive to store data and we would store just the data we needed to run our business to one where you could really consume and collect as much data as you cared to. And that actually had an effect on analytics as well. So if you look back to the roots of where statistics came from, modern statistics, I mean, it was born out of a time in 100, 200 years ago where sample sizes were single digits, n equals 7.
Right.
And and we suddenly, in the last 10 years in the world, where n is all or infinite, nearly infinite. And so that has changed the way people think about and use tools. A lot of the classic tooling, the really mature, great tooling for data science and analytics, like R, for example, wasn't designed for big data because why would it be? It grew up from S in the 70s and in a world where one big machine was plenty big to do most of what you needed to do. So that's why I think data science, big data influenced the evolution of analytics, because suddenly people needed a new set of tools to do analytics and machine learning on big data because it was a different problem. The scale was different enough that it required different tools and approaches. And so I think that's how engineers got stuck into the world of analytics, because it required analytics users to start thinking about these new engineering tools and projects like big data and Hadoop. And thus, data science was kind of born. I think data science is obviously a mixture of statistics and analytics, but also engineering and computer science. And it's necessary these days because you can't really separate the software issues from the analytics issues. When you are doing analytics today at scale, you're building software. You're using frameworks and libraries at close range. So those worlds have kind of come together, and I think big data maybe helps propel those two worlds together.
So that's a great segue into my next question. You talked about the evolution of big data with the cost of storage going down. The other part of this is, of course, the unstructured aspect of the data. So, going back for many years, enterprise data was always stored in a relational database, and it reached a point where it was not possible to store unstructured data. And so that kind of gave the rise to Hadoop, for example, with the Google file system, which eventually ended up being the Hadoop file system, and this MapReduce programming model. Can you talk a little bit about that? Because when people refer to Hadoop, again, so there is the storage part of it, and then there is the programming aspect of it as well.
Sure. I do think people often say, well, Hadoop's one of its magic tricks is that it can work with unstructured data. And in a sense, that's true. I think at the core of Hadoop is still a file system, and file systems can hold files, which can be anything. But no data is truly unstructured. I think that's actually a misleading term. All data has, well, any useful data has some structure. It just may not be conventional tabular structure that we're used to from the world of data warehouses and from the world of relational databases. In truth, though, to do analytics on data, you do need to extract some structure from the data. So you'll still see machine learning workloads in Cloudera, in the Hadoop and Spark ecosystem. I mean, start by getting a table of data, a data frame, because that's just how a lot of analytics still works. The difference is that, back in the day, we couldn't really afford to keep all the raw data and go parse it in real time to extract the structure we wanted or the pieces of the data we wanted. And Hadoop changed that. If it became cheap to store data, if it became cheap to compute, then you could really stick on in your data warehouse the original so-called unstructured data, which may be original images, original text files, and then go process that in a number of ways to extract structure, to label an image, to extract keywords from a document, and so on. So it's not that Hadoop can somehow use unstructured data. It's just that with enough storage and compute, you can afford to store larger, rawer data, and then go extract the structure you need dynamically at runtime because you've got the compute to do it.
So in terms of how this Hadoop ecosystem has evolved, it started off with Google coming out with the MapReduce programming model, and in fact, I was at Google this week. So Google does not use MapReduce anymore, right? I mean, it has now moved on to Spark streaming, for example. So even that particular ecosystem has evolved within itself.
Absolutely. Yeah, when I was at Google in 2004, yes, the MapReduce was fresh and hot, right? And GFS
Right.
and it took a couple of years for those things to come out, be re-implemented. Well, I guess really at Yahoo, and then out into the open source world. Credit to Yahoo for open sourcing their version of it. And pretty soon we had an interesting open source mirror of a lot of the stuff I saw at Google. So, we had instead of Chubby, which is a lock server, we had Zookeeper. And instead of, I don't know, Dremel, we had Hive. And that's nice. And that feedback loop has gotten interestingly rapid over the past 5-10 years. So more and more, it's amazing how much of this software we rely on in open source has come from these web giants who have built the stuff and then managed to open source it. And the feedback loop has gotten so quick that, the technology we have access to in open source is pretty current with what web giants are using. It's no longer a one-way street. For example, yeah, Google has long since gone off MapReduce. So is Hadoop, really. But I don't know if they use Spark streaming per se. They have, however, taken ideas from Spark and Flink and built their own interesting version of it, I would say, called Beam, that really sits on top of those two things, and they've open sourced that. So it's much more of a two-way conversation between the web giants and open source, and the winner is us, everyone who can benefit from all this stuff. The only downside is it gets really hard to keep up with what's going on. It's not just one project, it's not 10 projects, it's hundreds and thousands. It's a big web of interrelated projects, and it's hard to know what's new, what's going to stick around, what's hot, what's not. Even I struggle with that. We struggle with the name Hadoop even. I mean, Hadoop really technically speaking refers to this one core project in the middle,
Right.
To 1/3 of which is obsolete now. It's just like we talk about Linux. Linux is just the kernel, but really when we say Linux, we were talking about this huge ecosystem around it.
Right.
Sean, one thing that I learned, just taking it back to the business level, is that when I took my big data course, taught by Manjeet here, I mean, there was he talked about Google Bigtable and then the evolution of the Hadoop distributed file system, storage, having to deal with this quantity of data that's exploding, structured data as you're talking about, but also I'd like Manjeet and maybe yourself to talk about the languages that were created, namely Pig and Hive, and how that came out of Google and Yahoo. And because I think it suggests the point, what I got out of the class as a business guy is this is a very complex environment that is changing, that you talked about, and that correspondingly the skill sets needed to do this orchestration is really hard to come by. So when we see in the popular press, big data, can I mine it and get this gold? I see a skill set or, a very complicated, task or, program that needs to be managed. So, I mean, I think it's very interesting context to talk about Pig and Hive, just where that came from. Where was the skill shortages? Because I just went, wow, they created a language because not enough people knew Java. That kind of blew me away. And it's suggestive of the whole issue in and of itself.
Yeah, those are good examples. So Pig, Hive, you could argue a lot of these frameworks are higher level languages on top of a lower level frameworks underneath. For example, a Pig to me is like PL SQL on Hadoop, on MapReduce. Hive is SQL on MapReduce. And why, even if I know Java, I don't really want to write stuff in MapReduce. It's like the assembly of language of big data. So that's natural, and I think that's why we had things like Spark, for example. I mean, Spark really brought the functional programming paradigm, an even higher level version of what had already been improved for MapReduce with projects like Crunch, for example, or cascading. It took that to even another level, and that making things easier to use. It isn't just enabling people who don't want to spend 2 years getting into MapReduce to being friendlier to them. It's really about helping developers who know it perfectly well just be more productive. I mean, I understand MapReduce pretty much inside and out at this point, but I would never write such a job. I would always choose the higher level language that's appropriate to the task, whether it's SQL or PySpark or whatever meets my needs. And that's good news. So as the complexity has expanded because we're able to do more, we've tried to build layers on top that can at the same time reduce the complexity.
Right, and it kind of gives you a level of abstraction where it is much more easier to perhaps focus on the problem rather to focus on the code, where if you're writing an entire mapper, writing an entire reducer, just not only focusing on the problem, but how do I take this given business problem and then convert that into a mapper and reducer ends up being another set of problems, as opposed to having this level of abstraction provided by Hive and Spark SQL kind of takes that away from you, right?
Mm-hmm. That's right. And I think that's actually important to the story of data science and analytics. I mean, if you take your average R user and you ask them, are you a software developer? I think they would say no. R is it's a scripting language. It's an analytics environment. And it operates at a fairly high level as a result. And we had to build up to that level through things like Spark, really, in the end, to bring the language and building blocks to a high enough level that it's comparable to what you find in other high-level analytics languages like Python, Scikit, R, and so on. And that really then let a framework like Spark build a language bridge with PySpark, SparkR, SparklyR, to those analytics worlds. And now that's really changed the game in the past year or so. Now someone who's traditionally only worked in those analytics environments can walk up to Spark and this big data ecosystem and see usable primitives in the language they know at the level they're accustomed to working. And suddenly these worlds are no longer separate, they're really bridged. And that's happening this year, which is great, it's really exciting.
So since you brought up R and Python, there's this R versus Python war, right? I mean, people think that one. So if you know both, great. But if somebody asks me if I have to pick one, which would perhaps give me the biggest bang for the buck? What's your opinion on that?
Well, since it's just us talking here, maybe I can go out on a limb and have some strong opinions, right? I'm being a software developer. I don't like either of the languages as languages. I prefer Scala and JVM languages, strongly typed, compiled languages. But for analytics, no doubt those are two common languages people do use. Which one would I pick? Well, they're not quite comparable. I mean, R is a language, yes, but it's really it's important because of its huge library packages and ecosystem of work in the R language. So R is probably a more of a legacy language compared to Python. It's less general purpose. Python is more of a general purpose language and maybe a little more modern. And so for that reason, I think I would generally bet on Python because Python is still it still doesn't have quite the breadth of analytics packages that R does. It does have a lot, and it's better in some ways. For example, if you like deep learning, those packages are going to be in Python, not R, these days.
Exactly.
So I think if I was forced to choose one, I'd say Python. But you know me, I actually am a JVM person myself anyway.
That's great because at least in our data science program, we currently offer R, and then we are introducing a new course with Python. So that way we have both covered. Now, the evolution of Cloudera itself, when you had this Hadoop open source project, you had essentially three companies. You had Cloudera, MapR, and Hortonworks, which came up and they were offering this open source project, instead of an end user or an analyst downloading all of these libraries and then making them work together. Cloudera has done an excellent job in bringing all of these pieces together so that a person only focuses on the problem. How does Cloudera differentiate itself from the Hadoop distributions offered or the services offered by MapR or Hortonworks, for example?
Right. Yeah, I think Hadoop was clearly a big enough deal, 8 years ago, that not just one company formed to try to commercialize it, but three. And so I think, yeah, Cloudera has long been linked with those two other companies as Hadoop vendors. And in the early days, that was a pretty accurate description of the business. The product and the focus was largely around a tool, Hadoop. And that took everyone only so far, though. At the end of the day, a business person doesn't really need a Hadoop. They need a solution to their problem. They need a wider toolkit. They need things on top of this raw platform. So in a way, I think we would resist that characterization that primarily we compete against other Hadoop vendors and that we're all just selling Hadoop support and services. Certainly that's at the core, but even those distributions differ a fair bit around the core. Interestingly, one of the premises of Hadoop is no lock-in, right? Everyone's giving you the same Hadoop, so if you like, you can use one distribution today and another tomorrow, and that's great. And that's true at the core, but if that were true of the entire platform, there would be absolutely no difference between the distributions. So what would be the point? In truth, these different distributions do make different decisions about software they ship and support around the core. They make different decisions about what other software management tools to ship around the core as well. So while the core is Hadoop, yes, all these products, including Cloudera, are actually bigger platforms of tools. And so today, I think we like to present Cloudera as what we call an enterprise data hub. That's a big generic term, but it is actually a big generic platform. It's a place to store data, process data, secure it, do analytics, do machine learning. And it's under the hood, it's actually a bunch of open source software with some management tools around it. It's a big Swiss Army knife, but we don't really focus so much on that because, you know, the message isn't that we give you tools, is that we can help you solve problems. So differentiation, I mean, I think probably Cloudera has maybe more scale and has been able to invest more in the platform. I think we made some right decisions about what to include in the platform earlier. For example, I started getting involved in Spark in, late 2013 or so, pretty early, and we shipped that. And I think that's proved to be a good decision. So I think Cloudera would argue the core is the same. It has made better decisions about what to package around the core, and then has, of course, some differentiating products around that, like the management tools, like Cloudera Data Science Workbench, that aren't, strictly speaking, part of the Apache open source ecosystem, that represent the value proposition versus another one of these vendors.
Right.
In the end, these days, though, I think our competitors are more actually cloud providers and maybe the likes of your IBMs of the world.
Sean, I think that's a good segue. So I'm kind of the business guy, talking about how do we deliver this value in the data science realm. So what is the market needing to do, in your opinion, to harness, the power of big data? And when you're talking about solving problems, you could probably segue into your new product offering in Altus.
Sure. So yeah, what do we need to do to take advantage of big data? Well, let's think about the ingredients there. We're going to need data, sure, and we're going to need software, and we're going to need some skills, and then we need to figure out what to do with it. Two of those elements are pretty easy these days, I think. Software is free, computers are cheap, and skills is still difficult. But there's a lot of people who know the Hadoop stack, Spark these days, and hey, people that you don't have to learn Java anymore. Python developers can be productive on the platform too. I think two of the most important things businesses can do now are the pieces on the end, data and what to do with it. I think data is one of the remaining differentiators in this new era of big data analytics. If the software and the compute's commodity and skills are widespread or getting there, what differentiates company A from B is who has better data, who's better organized about their data collection. So one thing that just can't hurt anybody is to invest more in collecting data intelligently and collecting it, making sure it's clean and well understood and documented. That alone takes more effort than people think. And of course, you have to have a purpose too. Data by itself just sits there. It needs to be mined or interpreted to extract insights or build data products that do something with it. And could be surprisingly hard too. I think that is a new idea to businesses that aren't used to thinking about what data they could collect if they wanted to, if they could think of a use for it, and then going and productionizing those data products. So, I think focus on what would change your business and what data do you need to do it, and the rest is a bit of a detail that, hey, vendors can help with.
We talked about unstructured data storage earlier on. Now, in the NoSQL, which is not only SQL data stores, there are a number of offerings, right? There is HBase, MongoDB, which is a document database. You have a graph database like Neo4j. So how does one make that decision? That is, I have this unstructured data. Which NoSQL data store should I be opting for?
You're right. Just in the field of NoSQL stores, there are quite a few choices. I would add to that list Cassandra or React, which I think, unfortunately, the company might have been in trouble at this point. But over the years, there's been a lot of NoSQL stores. The one that comes with the Hadoop ecosystem and that's most tightly associated with it is HBase. So of course I'm going to say HBase, but to be honest, I've never, as a data scientist, I've never gotten deeply into using NoSQL stores myself. So I don't have an informed opinion, and you'll find people that swear up and down that NoSQL A is better than NoSQL B. In truth, they're all pretty mature at this point, and they make different design trade-offs, and so have different characteristics. Which one should you choose for unstructured data? Well, yeah, in a way, NoSQL stores are a good choice for unstructured data because their purpose is to serve up a blob and that's keyed by some key, and do that very, very fast and make sure things are eventually consistent when you update it. But so that's the right store if you need that kind of access pattern. If your data is frequently updated, if you need to frequently go query for one piece of data, you need a NoSQL store. But for a lot of machine learning workloads, you don't need that. You want to write a big data set once, and you're going to scan it in parallel serially to go build a machine learning model. For that, you just need something like HDFS. It's just a file system, and that's optimized actually for those serial scans. And in fact, NoSQL stores aren't very good at that. They're not optimizing for that. We have Cloudera launched a project several years ago that's now an Apache project called Kudu that attempts to be somewhere in between, have some of the best characteristics of HDFS and NoSQL stores. So you have one unified storage system that is pretty good at both access patterns. So I think the choice of those engines really depends not so much on data being unstructured, but being accessed in a certain way. A couple of the other tools you mentioned, I again associate with a slightly different type of data. For example, Neo4j, as you say, it's a graph database.
Right.
And that is a great tool if you need to do graph-like queries on graph-like data. Show me all the nodes that are 3 hops from this person or entity. If you don't have that type of data, it's just not the tool. But if you do, you want a specialized engine like that. So from a machine learning perspective, I think these stores I associate these stores more with runtime and production and operations. Analytics tends to proceed more on plain old, Parquet formatted data in HDFS. But in principle, you could use a lot of these could come into play in a data science or machine learning application.
Mm-hmm.
Sean, when we kind of bounce back from technical to a little bit of skill sets, but can you tell us a little bit about Altus? Because I thought that was intriguing and an interesting offering by Cloudera.
Yeah, sorry, I forgot to pick up on that. Altus, interesting. So if you think about what companies like Cloudera have offered to date, it's been a platform of software. And it's great if you want a lot of control over how that software is deployed and you want to kind of customize it and tweak it and own it and manage it. That is not necessarily a worthwhile overhead for a lot of access patterns. The cloud has kind of changed how people think about it. Before, yes, I would go buy 100 computers and I need to manage the software running on those 100 computers and run my workloads on it. With the cloud, I don't have to buy any computers at all. I can tap into compute resources and then let them go. And that changes how people, I think, approach software like the Hadoop ecosystem. It enables us to step back and maybe think more about what problems we're trying to solve, what workloads we're trying to run, rather than how we manage the machinery that runs those workloads. It ought to be simpler. I ought to be able to say, if I can easily describe my workload as a SQL query or a Spark job, I ought to be able just to go throw that at a service and have it go figure out how to execute it on my data that's in the cloud and go put that result into the cloud somewhere else. And I think that describes the idea behind the first product under this Altus umbrella, which is kind of this catch-all brand for a lot of our next generation of cloud-based offerings. That describes what Altus data engineering does. It's really a way to describe a workload and go have it run in the cloud. And really, if you like, you don't even have to know that there is a Cloudera cluster that's spun up and does the work for you in the background. And I think that's actually compelling. The more for workloads like that, bursty workloads, that's the level of complexity that's appropriate. And now you can keep it that simple, rather than have to go, set up your own cluster in the cloud and keep it running. You can just throw a workload at Altus, and it will go run the workload on the same stack, same Cloudera you're maybe using for your on-prem cluster, same security, same software, same versions, but just manage the details of that for you. It's AWS specific now, but I think the idea is this is the first and maybe several new ways we could present what Cloudera offers in a way that isn't just a ball of software, but more of a service.
Yeah, I mean, exactly. Sean, I mean, at a certain time as a business development director, trying to bring IoT products, which is at the top of the value chain, is analytics. And then you have the Cloudera product. At a certain point with exponential technologies that are changing, it's how do we deliver this solution and this value, and how is it digested? How does these guys consume these solutions? We know it's right, and we want to give it to the masses, but how do they take it and harness it? And that's what I felt really cool about Altus. After I took all these courses, and it's like, wow, there's some complexity here. And how does the mid-market embrace it and learn from it as we're going through this digital transformation, right? And I think that's I think the software guys are thinking more about business problems and solutions and value, right? And I think that's really cool.
And it is, and it's a good on-ramp for new organizations to try this stack and technology. I mean, it's not hard today to go spin up a cluster in the cloud. That's been available for a while with Cloudera Director, but it's still a little bit intimidating if you don't know the stack. You get a console with a bunch of services in front of you. And in contrast, if you look at what cloud providers themselves are offering, it is nice and simple, isn't it? I love the Google Compute Engine, for example. I'm an ex-Google guy myself. I really like the simplicity of it. And I think in a way we're trying to give people that simplicity as an easy way to get started with the platform as well, in a way that's still also scales up for real production jobs later. So yeah, I think it's an intriguing new direction for the company as we evolve beyond just giving you a big bag of software.
Yeah, I mean, we have to realize in the context of the day-to-day, I mean, people are running industrial companies, they're doing sales organizations, they're not historically data companies. And, there's a lot of failed data initiatives out there. So we got to show them and point them, as you said, to embrace complexity, but enough that they gain insights to go to step 2 and step 3 in this evolving process. And one question that I had, and when I deal with the mid-market size companies, is they actually don't have a lot of data. It's time series and it's rather limited. So as I get more and more into it, I mean, you can see the winners are the guys that have big data, and then they have the skill set to really mine that big data and have hyper customization and nuance, embracing that complexity. So, like, is there anything you can say to people if they need to acquire more data, so they can glean some insights, where they can go to acquire data sets or partner with companies? Do you have any suggestions?
Yeah, you'd think there would be easy ways to go get any data you want. And in fact, I find it surprisingly hard. I've seen data marketplaces come and go, and it is actually challenging to even share data, even if you didn't want to charge for it. And it's worth highlighting a couple non-obvious reasons that is the case. Number one, if it's true that data is really the differentiator, there's not a lot of companies that necessarily want to share their data. Or even if they did, it can take a while to figure out exactly what data you can share and what you can't, to make sure it's clean and makes sense, that it makes sense outside of your organization and isn't tied into your internal representations and IDs and table schema. And on a maybe more serious note, it's not clear you can even legally release some data. That data is not wholly yours, maybe, as an organization. It might have personally identifiable information. Even if you do a good job redacting it, was it 100%? Did you leave in some data that wasn't explicitly PII, but could be used to infer some PII? We all have heard of sometimes big lawsuits over data breaches where no one was hacked, but a company released data, maybe even for research and for the common good, but inadvertently released more than they thought. So it's fraught enough that I think it's hard for anyone to sell data, and you don't. So it's hard to go out and just grab useful data off the shelf. I'd also point out that if you think you're a data-driven business, you probably can't gain competitive advantage using commodity data, right? If everyone has access to a certain data set, then it won't really be a source of advantage. So for a lot of these reasons, it does seem like companies need to think about what data they themselves are entitled to collect and can collect and own, and focus on that as value, and something they should treat as a differentiator. That's not to say there's nothing you can do. There are wonderful public data sets out there, the stock market, weather, all kinds of government data sets especially. They've done a good job of making available some nice open data sets. So that it is possible. It's just it's harder than you think.
Yeah, and what I'm getting interested in is applying some data science to some old historical data where they've created great value. I mean, this is stuff that keeps machines vibration, so you get prediction when these things will fail. But I have a feeling, I mean, that some of that vibration expertise in subject matter, like these domain experts who've been doing this for decades, goes all the way back to the Manhattan Project. So it's dated, but it works. And I'm wondering if we can combine some data sets, just because they haven't had the tools to experiment statistically or from cloud computing, to be able to just get new normative data. Now, it might not be perfect, but it could be indicative and it could be illustrative. You know what I'm saying? So that's what I get really excited about, is like, hey, can I get this old industrial guy with a guy like Manjeet or Sean, and can they looking at the problem different, just from a purely exploratory perspective?
Yeah, I know what you mean. Well, interesting you phrased it that way, that it sounds like you really are interested in capitalizing on the experience that these companies have built on their data. And in the world of machine learning today, you can maybe do that without having the data literally. This is, I think, been emphasized by the rise of deep learning, where people can actually build these big deep learning models where half of the model, lower layers of the model, are reusable. They effectively become generic feature detectors that could be reused by other people. So, for example, if I'm Google, I can build a huge deep learning model on all the images in the world, and then actually release most of it to the world as the foundation that they can go build their model on top. So I'm just throwing a thought out there. That may be an interesting way that companies or organizations share knowledge, not as raw data, but also as trained machine learning models or parts of machine learning models. That's also viable these days.
Sean, so as you know, I teach a number of data science courses here at the University of St. Thomas. So the educator in me would like to ask you two questions. We talked a little bit about the abstraction provided by Pig and Hive, and Hive, Impala, which of course does not use MapReduce, but there is Spark SQL. All of these, follow the SQL kind of a syntax, and then you have Pig, which follows a data flow model, and it is very easier for students to understand and analyze data stored in HDFS. In recent times, Pig is not as popular, and at the same time, though, if you look at the job postings, there is still a demand for that particular skill set. Um, in your opinion, should one be investing time in learning Pig, maybe for legacy code purposes?
Yeah, I think I share your view that it's not as widely used today. Although I'm not surprised that there are big existing Pig users and installed bases. I mean, it's still in CDH for sure. We still have people using Pig, certainly. If I were learning today, I think I would focus on Spark. I think Spark, in a way, took over the role that the Pig was playing. Pig is, yes, it's more flexible than SQL. I always thought of it as reminiscent of PL SQL, but it was a data scripting language. And I think you can get most of the same effect, the level of expressiveness at the same level through a Spark program. And I think that has advantages. If at least you are just using Spark and don't have to learn a different language and framework. And Spark, of course, is accessible through 3 different programming languages. And once you're in Spark, yeah, some more stuff is possible as well, because Spark's got a fair bit of stuff built into it. So I think on that note, I would tend to steer people towards Spark if they're interested in writing fairly high-level scripts that manipulate big data.
And my second question is with regards to, I teach a number of students here who, in their prior background, in their undergraduate degrees, may or may not have a degree in engineering, computer science, mathematics, and they are trying to make the transition into becoming a data scientist today. So what are the skills or perhaps a background required today to become a successful data scientist?
Yeah, good point, good question. So I think if you look closely at most jobs that are advertised as data science jobs, they end up being more engineering than anything else. In my experience, most companies that want to hire for that role, people come in and end up working on a chunk of software. They end up figuring out how we're going to get log files from this machine into a cluster. They end up figuring out how we're going to transform them. And only then at the end does someone figure out how to do the machine learning bit. So if that's true, if one agrees with that, then I would say that your first skill is probably some software development, some understanding of a programming language that's relevant to analytics, like, well, Python's not a bad choice. And an understanding of how to pair that with data infrastructure, like Spark, for example.
Right.
That's pretty powerful. If you know that, you can contribute to a team that is doing data science. You'll be more on the data engineering end of it, but that's where most of the work is. SQL doesn't hurt either. That's still comes up quite a lot. The concepts come up a lot. I think to really be a full, quote, data scientist, you have to be more than just a software engineer. I do think there is a skill set difference. I think it is both the software engineering discipline, but also some statistics discipline as well. So I think eventually one does need to acquire basic stats, probability, linear algebra background in order to understand what some of these tools that they're used to in the software libraries, what they're actually doing, what it means. and to know the things you don't otherwise know about what you might be doing wrong, and how to interpret the results. So I think that is ultimately important. But for someone who's more specifically interested in first jobs and job prospects, I would tend to focus on the software engineering side of things.
Sean, this was a really great conversation, and I'm sure this would be really useful for our listeners. We would like to thank you for your time.
Thank you very much. You all know everything I know now. That's all I know. So I hope it was useful. I enjoyed it too. Take care.
Sean, one last question. Is there anything
Sure.
that you want to share with the audience? Anything cool that's inspiring you lately?
Well, let's see. I think on my team, the data science team at Cloudera, part of our remit is to go try and figure out what's cool and interesting and talk about it. And we're big into deep learning these days, not just distributed training on the cluster, but on things like GPUs. So we are playing with tools like TensorFlow and Keras, and it's nice that that's now usable on a CDH cluster through things like Data Science Workbench. So if you go to the Cloudera blog, you'll see some blogs from us about our adventures with deep learning, and I think that's been the most fun we've had in the last year.
Awesome.
Great. Thank you all.
Thank you.
Take care.
Bye-bye.